So I want to think again. I want to give you another analogy for thinking about how these things relate, okay? Now, I'll just give you a warning, okay? You might not like this analogy because it's sort of related to physics, okay? And I know not everyone likes physics, okay? But number one, I think it's a helpful analogy. Number two, you will have to deal with this idea next year when you deal with a topic called motion, okay? So if you would like to not do that, even 2 unit students do motion. So you will have to drop maths if you really dislike this idea that much, okay? So here we go. Do you remember the other day I took the apple, right, and I tossed it up and down, and then I drew it, right? I sketched it, okay? So in that case, our vertical axis, which we usually call y, corresponded to location, okay? Or if you like, if you want to use a more specific word, it corresponded to displacement, right? How far was I displaced from my original starting point, which was my hand, okay? Yeah. Well, at the start it was, but then when I tossed it up, you know, it wasn't at 0 anymore, it was other places. Exactly. Okay, now, that's location of displacement. Now, when I differentiated, what did I get? Okay, well, this derivative is how this is changing over, you know, the horizontal axis, which we name time, okay? So really, how is displacement changing? How is location changing? We have a name for that. It's called speed, right? Because when we say 30 kilometers per hour, what that means is, how is your displacement changing over a given time period, okay? But instead of our horizontal axis being time, usually our horizontal axis is x, okay? So how is y changing as x changes? If you wanted to be, again, more specific, you would say velocity, okay? Because actually direction matters and speed is just an absolute value. Okay, now therefore, can we fill in the analogy, okay? If this is how this is changing, velocity is how displacement is changing, what name do we give to the rate at which velocity is changing? And the answer is acceleration, right? So what this corresponds to is, okay, how is your speed changing over time? So as you put your pedal on the foot, okay, your speed isn't just staying at 30 k's an hour. Sorry, pedal on the foot. Foot on the pedal, okay? Or, you guys didn't catch that until 10 seconds. Anyway, yeah, that's okay. Now, by the way, acceleration here, this is where the analogy breaks down, okay? Because I would say if I've got my foot on the pedal, right, that's acceleration. But if I put my foot on the brake, normally we would not say that's acceleration, right? Because you're getting slower, right? But actually, it is acceleration in the sense that my velocity is changing. It's just that it's slowing down, right? So that's like the first part of the graph, okay? That part there, okay? So I'm still increasing, but I'm slowing down. The brakes are on. So I'm accelerating. It just happens to be in that direction, okay? Which, by the way, is what gravity was doing when I tossed the apple up and down, okay? It was, if you like, again, this is the physics language talking. This is the language of forces. Okay, you've got something that's pushing in another direction, okay, and changing the velocity, okay?